Hi everyone, my name is Daniel. I'm a third-year orthodontic resident at the University of Toronto. Today I'd like to share my latest creation called Supercalculator. Supercalculator is a new tool released to my website, orthocalculator.org. The focus of my website is using the mathematics of orthodontics to treatment plan cases. Supercalculator was created to help orthodontists plan extraction patterns that address sagittal discrepancies and arch asymmetry, if present, at the same time. Let's take a closer look at how Supercalculator works. There are 3 steps to using the calculator, which we will review. First, you make your diagnosis. Second, you plan your extractions. And third, you review the predicted outcomes. Before we jump in, please keep in mind that the 4th tooth back in each quadrant is the key tooth to focus on. This is usually the first premolar. Step 1, entering your diagnosis. The calculator utilizes the CATS classification of malocclusion. This is a millimetric method of classifying your malocclusion at the level of the 4th tooth back. A class 1 occlusion would be called CAT 0, a full cusp class 2 malocclusion is CATS plus 7, and a half cusp class 3 malocclusion is CATS minus 3. You simply enter these values into the diagnosis section of Supercalculator. This section also considers arch asymmetry by comparing the AP positions of the 4th tooth back in each quadrant. In this example on the left, tooth 2-4 is 3 millimeters ahead of tooth 1-4. You can enter this into the calculator. Notice that the mandibular asymmetry is automatically calculated based on the previous 3 inputs because the 4 values are all pieces of the same puzzle. To clarify this concept, let's consider a half cusp class 2 subdivision right patient with a CATS of plus 4 on the right and 0 on the left. In this case, the asymmetry could be all in the mandible with 4 millimeters ahead. It could be partially in the mandible and partially in the maxilla, or it could be all in the maxilla with tooth 1-4, 4 millimeters ahead. Step 2, extractions. Here, you select the teeth you're considering extracting with the type of anchorage you will use. For moderate anchorage, think power chains. For absolute anchorage, think TADs. Your extraction pattern will affect the predictions calculated in step 3. The calculations are based on Creekmore's rules of thumb for space closure, which describe how extraction spaces tend to close with moderate anchorage. Upper 5 spaces tend to close 1/3 from the front, 2/3 from the back. Upper 4 and lower 5 extraction spaces tend to close half from the front and half from the back, and lower 4 extraction spaces close 2/3 from the front, 1/3 from the back. Differences are thought to be related to the number of roots in each anchorage unit and bone density. Step 3, outcome predictions. Based on the diagnosis you input and the extraction you selected, the predicted residuals are calculated below in real time. This allows you to try different extraction patterns until you find one that works for your case. We want the sagittal and symmetry predictions to be as close to 0 millimeters as possible, indicating that there are no discrepancies remaining. Let's tie this all together with an example. We'll start off with an ideal occlusion. CATS is 0, 0, and premolars are symmetric in both arches. Let's now turn this into a malocclusion. The measurements we get are 4 millimeters class 2 on the right, 1 millimeter class 3 on the left, 1-4 is ahead of 2-4 by 2 millimeters, and 3-4 is ahead of 4-4 by 3 millimeters to simulate a mandibular asymmetry. We would punch these numbers into our diagnosis section of Supercalculator. And now we can play around with some different extraction patterns. The extraction pattern that I came up with ahead of time to treat this malocclusion is extraction of 1-4, 2-5, 3-5, and nothing in quad 4. Let's remove these teeth. 1-5 now becomes the 4th tooth back in quad 1 as shown by the pink marker. We can now predict space closure based on Creekmore's rules of thumb. Let's simulate that diagrammatically and see what we are left with. The calculator residuals using Supercalculator and the simulation have worked out to essentially the same thing. All of our residuals are now less than 1 millimeter. Because we extracted the right teeth, the remaining discrepancies can easily be corrected with minimal elastic wear. In conclusion, Supercalculator is a tool to help orthodontists plan extraction patterns mathematically. It allows us to get away from conventional extraction patterns and customize our plans to our patients' unique needs. By extracting the right teeth, we minimize our reliance on patient compliance with their elastics, leading to predictable and efficient treatment outcomes. Supercalculator is currently available on my website, orthocalculator.org. I invite you to give it a go on one of your upcoming cases and see what you think. Thanks very much for listening.